Assalamualaikum, this is Nan and today we're going to talk about the medulla oblongata. We're going to talk about the general facts about medulla oblongata, the gross appearance of medulla oblongata, the embryology of medulla oblongata a little bit, and finally the internal structures at different levels of medulla oblongata. So let's start. Medulla oblongata. The medulla oblongata is a part of brainstem present in the posterior cranial fossa. It connects the pons which is present superior to it with the spinal cord which is present inferior to it. Now, the junction between the medulla and the spinal cord is at the foramen magnum, which is the point of the origin of first cranial spinal nerve. Now, talking about the gross appearance of the medulla. Anteriorly, we can see an anterior median fissure in the medulla. Here is the anterior median fissure in the medulla. Now, lateral to this fissure is present pyramids, which are the swellings due to the accumulation of corticospinal fibers. The median fissure, lateral to it is the pyramid, the swelling of the corticospinal fibers. Further lateral to the pyramids are the olives, which are the swellings due to the inferior olivary nucleus. These are the pyramids, and lateral to them, posterior lateral to them are the olives. These are the olives present on both sides, swelling of the inferior olivary nucleus. Now, talking about pyramids, the pyramids narrows inferiorly because this is the point where the fibers of the corticospinal cord decussate. Decussation means the fibers on the right side move to the left side while the fiber on the left side move to the right side. Here the cut section, and you can see that the corticospinal fibers move from the right to left and left one move from the left to the right. This is the point of decussation. Now, above the decussation, from the anterior median fissure arise the anterior external arcuate fibers, which pass from medulla to the cerebellum. They have the role of passing sensory info to the cerebellum for coordination. Now, posterior to olives are present the inferior cerebellar peduncle, which are posterior to olives, and their role is to connect the medulla to the cerebellum. This is the posterior view of medulla, and here we can see that the inferior cerebellar peduncle, which are posterior to the olives here, and on the posterior we can see that these are present posterior to the olives, inferior cerebellar peduncle. Now, between the olives and the inferior cerebellar peduncle, we have discussed now, there are the roots of glossopharyngeal nerve, vagus nerve, and accessory nerves. Here we can see that this is the olive, and posterior view we can see that the inferior cerebellar peduncle. Between them are the glossopharyngeal nerve root, vagus nerve root, and accessory nerve roots. Now, posteriorly we can see the posterior median fissure. Here is the posterior median fissure of medulla. Now, inferior half of the medulla on the posterior aspect contains the central canal, which is similar to the central canal of the spinal cord, while the superior half, this central canal expands to form the cavity of the fourth ventricle. Here the central canal in the middle of the spinal cord. Now this central canal moves upward and expand to form this area, which forms the cavity of the fourth ventricle. Posteriorly, we can also see swellings like gracile tubercles and cuneate tubercles, which are due to the nucleus gracilis and nucleus cuneatus. Now, a quick recap is that the nucleus gracilis control the legs and the nucleus cuneatus control the hands. Both of these give rise to the dorsal column medial lemniscus tract, which is an ascending tract, means to say that it's a sensory tract. Now, a general overview of medulla include that medulla consists of the white and grey matter, which is extensively rearranged when we compare it to the spinal cord. This is due to the embryological rearrangement. Embryologically, this is the neural tube in which this is the neural cavity, and alongside with it forms two plates, that is basal plate, which give rise to the anterior grey horn of spinal cord, and this is the alar plate which gives rise to the posterior grey horn of the spinal cord. Now, when these plates move upward, the alar plate, which is present on the posterior aspect, move anterolaterally in such a way that when it reaches the medulla, the alar plate moves lateral to the basal plate. So what I am trying to say that the structures which give which the basal plate and alar plate give rise in the medulla in the spinal cord in the anterior and the posterior aspect will be connected to the structures in the alar plate in the lateral aspect of the medulla and the basal plate in the medial aspect of the medulla. Now, talking about internal structures of medulla, we can divide it into 4 levels. The first level include the level of pyramidal decussation. We call this level the level of great motor decussation because a number of motor fibers decussate here. Now, talking about the corticospinal tracts which form the pyramids of medulla, the decussation of 3/4 of the corticospinal tract occurs at this level. It is immediate to the spinal cord, which give rise to the lateral corticospinal tract. Now, if we recall, the corticospinal tract is present in the pyramid, which is a medial structure, and the medial structure are formed from the basal plate of the medulla, which give rise to anterior grey horn in case of spinal cord. So the lateral corticospinal tract will be connected to the anterior grey horn embryologically. Now, talking about the fasciculus gracilis and cuneatus, which appear as a swelling, they appear in the cross section to be the posterior extension of the grey matter. Here we can see that on the posterior aspect of cross section, the fasciculus gracilis, below which is the nucleus gracilis, and fasciculus cuneatus, below which is the nucleus cuneatus, and we can see that these appear to be the extension of the central grey matter. In the cross section, we can also see the central canal, means to say that there is no fourth ventricle at this level, and we can see the nucleus or spinal tract of trigeminal nerve. Here is the nucleus of the spinal tract of the trigeminal nerve present at the posterolateral aspect, and here are the fibers which arise from this nucleus. Now, fun point here is that since it is at the posterolateral aspect, so it will connect to the posterior grey horn. Why? Because the lateral structures of medulla are given by the alar plate, which give rise to the posterior grey horn in spinal cord. Specifically speaking, in the posterior grey horn, it is connected to the substantia gelatinosa. Now, talking about the second level, that is the level of lemniscal decussation. We call this the level of great sensory decussation. Now, this level also contains the central canal, and it occurs posterior to the pyramids. That is, the decussation of the lemniscus occurs posterior to the pyramids. Now, what is a lemniscus? Lemniscus is a Greek word meaning ribbon. So, it is a bundle of nerve fibers in the form of a ribbon. Now, these lemniscus are formed from the internal arcuate fibers, which arise from the nucleus gracilis and nucleus cuneatus. Here we can see that the cross section at the level of lemniscal decussation. These are the nucleus gracilis and cuneatus, and fibers from these, known as the internal arcuate fibers, move laterally and then medially to decussate at this point. Here the decussation is occurring. Other structures we see at this level include the nucleus or spinal tract of trigeminal nerve, the spinothalamic tract, and the spinocerebellar tract. Here we can see that the nucleus of the spinal tract of trigeminal nerve and the fibers arising from these nerves. Here we can see that the pyramids, we can see that the posterior and the anterior spinocerebellar tract, and lastly the lateral spinothalamic tract. Now the anterior spinothalamic tract is also present here, but it is not visible because it is present deep to them. Now the most important level, that is the level of olives. These contain the central canal which gets converted into floor of fourth ventricle. Now in the olives, the concentration of grey matter increases because of a number of nucleus present at this level. One of the nucleus include the olivary nuclear complex, which consists of inferior olivary nucleus, and recalling from previous points, this give rise to the olives which are present lateral to the pyramids on the anterior aspect of medulla. So these olivary nucleus are the largest of the olivary nuclear complex. Other include the accessory olivary nucleus like the dorsal and the medial accessory olivary nucleus. Here is the cross section at the level of olives. This crumpled bag-like nucleus, whose shape is toward the whose opening is toward the medial side, is the inferior olivary nucleus, and you can see that how large it is. Now at the dorsal aspect of this is the accessory dorsal olivary nucleus, and at its ventromedial aspect is the accessory medial olivary nucleus. Other nucleus include the vestibular cochlear nucleus, which consists of vestibular nucleus and the cochlear nucleus. The mnemonic includes for the vestibular is the MIV, that is the medial vestibular and the inferior vestibular. The mnemonic for cochlear includes the CAP, that is anterior cochlear and the posterior cochlear. Here we can see that the vestibular nucleus here and the vestibular nucleus here, that is this one which is the inferior vestibular nucleus and this one which is the medial vestibular nucleus, and the mnemonic was MIV. Now the cochlear nucleus include the small one, the posterior cochlear nucleus, and the one anterior to the inferior cerebellar peduncle, that is the anterior cochlear nucleus, and the mnemonic was CAP. Now important thing here is that at the level of olives, the cochlear nucleus is too small to be noticed. Other nucleus include the nucleus ambiguous, which is a collection of large motor neurons and present deep to the reticular formation. The fibers from the nucleus ambiguous joins the glossopharyngeal nerve, the vagal nerve, and the accessory nerve, and this marks its importance. Now the reticular formation, we have said that the nucleus ambiguous is present deep to the reticular formation. What is the reticular formation? Reticular formation is a diffuse mixture of nerve fibers and cells which are present deep and posterior to the olivary nucleus. Here is the olivary nucleus, and posterior to it and deep will be present the reticular formation. Now talking about the central grey matter of the olives. Now central grey matter is present beneath the floor of fourth ventricle, and it contains, if we move from medial to lateral aspect, 4 types of nucleus. The mnemonic for which is HDTV, the high definition TV, television, HDTV. Here is the floor of the fourth ventricle, and beneath is are present the nucleus of the central grey matter. Now we have made the mnemonic HDTV. When we move from this side, from medial to lateral aspect, we see the hypoglossal nucleus, dorsal vagal nucleus, tractus solitaris nucleus, and inferior vestibular nucleus. Hypoglossal, dorsal vagal, tractus solitaris, and vagal, inferior vagal. Now you should be thinking that the cochlear nucleus is also appearing here, but why we are not containing it into these nucleus? As I have said before, the cochlear nucleus is very small at the level of olives to be noticed. So we don't consider it here. Now another nucleus which can be seen at the anterior aspect of the pyramids are the arcuate nucleus, which are thought to be the inferior displacement of pontine nucleus which are present above it. Here is the arcuate nucleus. So other lemniscus and fibers bundle include the medial lemniscal, tectospinal tract and the medial longitudinal fasciculus. Here these are the fiber collection, and from the anterior to the posterior aspect we see the medial lemniscus. Here medial lemniscus whose role is of sensory input. Okay, so then we see the tectospinal tract which is involved in the spino-visual reflex, and at the posterior end we see the medial longitudinal fasciculus which connected the vestibular and the cochlear nucleus here with the nucleus of the extraocular muscles. Lastly, talking about the level which is just beneath the pons, there are no major changes at this level. The only change we see are that the lateral vestibular nucleus, which is the posterior aspect of the medulla, replace the inferior vestibular nucleus which we have discussed here. While the cochlear nuclei, which I have told here that they are very small to be visible, the cochlear nucleus become visible at the level just beneath the pons at the anterior and the posterior aspect of the inferior cerebellar peduncle. Here we can see that these are the posterior and the anterior cochlear nucleus which have become large enough to be visible. And here the inferior vestibular nucleus has been replaced by the lateral vestibular nucleus. So that was all from Medulla Oblongata. Please subscribe the channel and thank you.